Question 2 in our rates in equilibrium practice test number 2 is this. The following reaction can occur to completion in an aqueous solution. This is our reaction. Here is an energy profile diagram. What are our questions to do with this? A reaction can occur when a CH3Cl molecule and a hydroxide ion, what happens? Every time they collide, no. They have to collide with the right amount of energy, which in this case is activation energy, which is X. Only collide with exactly the activation energy X? No, they can collide with more energy than X. Only collide with the energy equal to Y take away Z. So Y take away Z is going to be a negative number, so that's not right. That can't be right because Y is smaller than Z. Only collide when they collide with energy greater than or equal to X. That's correct. That's by definition what collision theory is. A reaction is going to occur when molecules collide with enough energy to be successful, and that is the activation energy. So they can collide with the activation energy or they can collide with more than activation energy, and that's still okay. A catalyst appropriate for this reaction will affect what value? So let's look at this. What does a catalyst do? It decreases the activation energy. The amount of reactants product stays the same. So a catalyst is going to do this. All right, so if I just put the dotted line in there. So what is a catalyst going to do? Is it going to affect the value of X only? So the value of X will decrease, but so will Z. So it's not X only. Y only? Y is not going to change at all because a catalyst does not change the delta H. So that's not right. X and Z only, that's looking pretty good, and it's not going to be that. It's going to be C. And that's by definition and by using a diagram or annotating my diagram to say what happens when a catalyst is added to it. So this is my energy profile diagram. By definition, okay, a catalyst decreases the activation energy, so it lowers this hump here. And I can see clearly that X decreases because it's going to be here, and Z decreases as well because the hump has gone down to only here. So question C here, briefly outline one method that could be used to measure the rate of the chemical reaction shown above. So this is our chemical reaction here. What can I use to actually measure this? Well, I'll need to find how much has either been produced or how much has either been used. Looking at this, I can see something that I can measure really well, which is OH. You should identify OH as being basic or alkaline, which is the opposite of acidic. But basically, OH can be measured using pH. So I'm going to come up with a process that will be using to measure the OH. So an outline, a method, I would first of all have to record the initial concentration of OH minus, all right, via the pH. So if I know it initially, I can then measure how the pH changes over a period of time. So they're the two things I need to do, and as a briefly outline it, so I'm not going to go into much detail here, but I'm going to measure how the pH changes over a period of time. Now, I can't do that unless I first of all know the initial pH, and I can ensure that that is consistent. I might put in there as well. Ensure the concentration of OH is consistent in each trial. Unless that's what we want to change, actually. There actually is no reason why that has to be in there. Because all I'm doing is measuring the rate of a chemical reaction. So therefore, as long as I can record the change in that over time, that's important. All right, so that's pretty much it, actually. I don't even need that. It's fine to leave that in. I'm going to leave it in because if you want to look at what affects the rate of reaction, chances are you're going to be looking at something like temperature or something like that. In that case, you need to make sure that that's consistent each time before you start. However, you probably don't need to ensure it's consistent each time. Anyway, that's the question there, and I think that's the most reasonable thing. Main thing is here, if you want to measure the chemical rate of reaction, you need to find a way of measuring these things here. All right, I don't really know how to measure this stuff or this stuff or this stuff. Technically, this could actually be probably measured using litmus paper as well, because I think chloride ions might bleach it. No, chloride, they don't do that. Never mind, ignore what I said there. The only way that you should have an understanding of this is to measure pH, because that's going to measure hydroxide ions. Well, pH is going to give you concentration of H positive, to be fair, and that's in balance. That is on a seesaw with concentration over H minus. So therefore, you can see as pH increases, the concentration of that increases. As pH decreases, concentration of that will decrease. So therefore, what you should see is as this reaction progresses, the pH should decrease. And that's probably just me, again, over-analysing a question, but gives you an idea about what you should be looking at when you're reading these questions. What do I know about OH negative? It's related to pH. And as pH increases, OH negative increases. As pH decreases, OH negative decreases. This reaction uses that, so what we should measure is the rate of decrease in OH minus, which is the rate of decrease in pH. Key thing here is we're looking at rate as well, so therefore we need to have some indication of time in there. So you need to know the pH change over a period of time, a set period of time perhaps, and that way you can get rate. That's probably enough for that question.